When you think about firefighting, what comes to mind? Probably huge trucks, right? Powerful hoses. But what if the very first line of defense against a fire in your home wasn't a team of people, but just one tiny robot? We're about to look at a super cool project that puts an autonomous hero on a mission to stop disasters before they can even get started. It really does sound like something straight out of science fiction, but honestly, it's closer to reality than you might think. Just picture it. A small, totally autonomous guardian just patrolling your home or your workshop, ready to spring into action at the very first flicker of a flame. And that's the big idea we're going to dig into. So let's go ahead and meet our little hero. It's called the firefighting car, and its job, well, it's simple, but it's absolutely critical. It's designed to be an autonomous fire suppression system, built to handle a problem long before it has a chance to become a full-blown catastrophe. And the key word here, you guys, is real time. This isn't some scheduled task, it's in a constant state of alert. The whole point of this machine is to autonomously detect, navigate to, and then extinguish a small flame the very moment it appears. That's the tiny window that makes all the difference, right? It's the difference between a small scare and a major disaster. Okay, so how in the world does a little car like this pull off such a massive job? To really get it, we've got to pop the hood, so to speak. Let's break down the anatomy of this robotic firefighter, piece by piece. What's really cool is how elegantly simple the design is. You've got a brain, that's the Arduino Uno, to make all the decisions. You've got senses, the fire sensors, to see what's going on. It's got mobility, thanks to the motor driver, and of course, the tools for action, the water pump and servo. All right, let's take a closer look at how each of these pieces does its part. First up is the brain, the Arduino Uno. This little microcontroller is pretty much the heart of the whole operation. It takes in all the data coming from the sensors and, based on its programming, it makes every single decision: which way to turn, when to move, and most importantly, when to spray. It's the one calling all the shots. Of course, a brain can't do much without any info, right? That's where the fire sensors come in. Think of them as the robot's eyes. And having 3 of them is so clever because it means the robot doesn't just see the fire. It knows exactly where it is. It can triangulate the location and figure out the most direct way to get there. So, once the brain knows where the fire is, the robot's got to get there. That is the job of the muscles, the motor driver, and the 4 DC motors. This system basically takes the orders from the brain and turns them into actual movement, pushing the car left, right, or straight ahead, right toward the hazard. And now for the final act. Once the robot rolls up on the scene, it's time to deploy the tools. There's a servo motor that acts like a quick, nimble wrist, aiming the water nozzle with perfect precision. Then a small but surprisingly powerful pump kicks in, delivering a targeted stream of water to douse that flame. Okay, so we've got the brain, the senses, the muscles, and the tools. We've seen all the individual players. But the real magic happens when they all work together in this perfectly coordinated mission. So let's see how it all comes together in this seamless sequence. It all boils down to this super smart 3-step dance. First up, detect. The sensors are always scanning, and the moment they spot a flame, they lock onto its location. Second, navigate. That Arduino brain immediately tells the motors to get moving, straight to the target. And finally, extinguish. Once it's in position, the servo aims and the pump goes to work. I mean, it's just this perfect little loop. Sense, think, and act. All on its own. This thing is obviously a really cool piece of engineering. But why it matters? Well, that goes way beyond just the nuts and bolts. Let's pull back for a second and look at why a project like this simple little car is actually a pretty big deal. And this is where you see the project's true value, because it really serves this powerful dual purpose. On one hand, yeah, it's a practical safety device, an autonomous guardian that could protect our homes. But just as important, it's an incredible educational tool. It's this amazing hands-on way for students and hobbyists to really get their hands dirty and learn the fundamentals of robotics, coding, and automation. And really, that's the takeaway here. This isn't just some fun hobby project. It's a serious proof of concept. It proves that even small, accessible smart embedded systems can prevent hazards and protect lives. That's the real potential here. Simple tech, solving huge, life-threatening problems. It's amazing stuff. So, all of this leaves you with a really exciting question to think about. We've seen how this technology can take on a fire, but what's next? If a tiny robot can be a first responder for flames, could another one detect a water leak before your whole kitchen floods? Or what about a gas leak? Seriously, we're just scratching the surface of what these tiny, smart guardians could do for us.